Hey everyone, welcome to your asynchronous math lesson for the day. So the way we're going to do this is we're going to do the practice problems for Unit 7.6 Lesson 4 in our Desmos workbook. So we're going to work in paper today just to mix it up. And also because if we put this stuff on paper, especially some of the equation stuff I'm going to teach you, it'll be in your workbook for when you have to take your next quiz a while down the road. It's not coming up anytime soon because you just took one. But when you do, you're going to have all this equation stuff on a page that we're going to write back here that you can look at like while you're taking a quiz. So go ahead and grab your book. If you have to pause the video for a second, go grab your book. But this is page 80 that we are on. We're going to do page 80 and 81. All right, so I'm going to assume you have your book now. Pause it if you need to grab it. Let's start with this warm-up. We got some fraction multiplication. So multiplication is the easiest of all the operations you can do with fractions because it works the way you wish it would, right? You just do the top number times the top number and the bottom number times the bottom number. All the other operations with fractions, there's like extra stuff you got to do, like flipping things or common denominators, right? Multiplication, easy. So I'll do a couple of them, and then I'm going to encourage you to pause the video, do a couple on your own, and then press play on the video and see if you get the same answer as me, rather than just straight copying me. I can't really force you to, and I'm not going to like wait myself. So, but you'll get a better learning experience if you try some things and then see if you get the same as your teacher rather than just watching all the time. So 2 times -4 is -8, and 3 times 5 is 15. So the product of these two fractions is -8/15. Remember, product is what you get when you multiply two things. Let me zoom in a little bit. And remember, that can be written as -8/15 or -8/15, or you could even write it as 8/-15, but nobody does that. That's so weird. Don't do that. I mean, you can, but don't. All right, the next one, I'm noticing that these two are what we call multiplicative inverses of each other, aka reciprocals, right? They're the same numbers, just flip top and bottom. Well, except for that negative symbol, but whatever. And so I know that when I multiply these, I'm going to get the same number on top and bottom, and then that's just going to like reduce down to a 1, except there's going to be a negative there, right? So 5 times 7 is 35, so I got -35 on top, and 7 times 5 is 35, so I got 35 on bottom. 35/35 makes 1, but it's -1. All right, pause the video here. See if you can do the other two without me. This right 39 is 39/1 to help you do it. All right, so maybe you paused it and did them, maybe you didn't, I don't know. 2 times 39 is 78, but it's -78 because of that -2. And then 39/1, or 39 times 1 is 39. Well, 39 goes into 78 2 times, so this is really just -2. You could have figured that out by doing some cross canceling. You might have been taught this before. When you're dealing with fractions, if you're simply multiplying and you know that you have the same number on top and the same number on bottom, then you should be confident that this is going to happen every single time. That number is going to wind up being a factor of both the top and bottom of your new fraction, and it's going to just wind up simplifying out. So you can cross cancel, sort of like do the work ahead of time. You can be like, oh, 39 on top and 39 on bottom, I don't need those. I can turn them into 1s. And then what happens is you get -2 times 1 equals 2, and 1 times 1 equals 1. So you wind up with -2/1. Same thing we got, right? All right, and the last one here, we got 2 times -3 on top, and 5 times 4 on bottom is 20. Now I notice that, oops, way off screen. I notice that 2 goes into both -6 and 20, so I can simplify this by 2. That's going to equal -3 over 10, right? I divided the top and bottom by 2. And look, you could have skipped that step if you noticed that on the top of this fraction was a 2, and on the bottom of this fraction was a 4. So there's a factor of 2 on the top of this product and a factor of 2 on the bottom of this product. So take 2 out of this 2, and it becomes 1. And take 2 out of this 4, and it becomes 2, right? Because you're like dividing that 4 by 2. And what you get is 1 times -3, -3. 5 times 2 is 10. So, you can cross cancel or not. It's always just okay to just multiply straight through and then simplify at the end. In fact, that's usually how I do it. But, it's nice to know that there's other options out there. All right. Next, it says, a school ordered 3 large boxes of markers. Each one of these compartments in the tape diagram is supposed to represent a box of markers. So this is box 1, this is box 2, and this is box 3. After giving 15 markers to each of the 3 teachers, there were 90 markers left. The diagram represents the situation. How many markers were originally in the box? So X is actually going to represent the original number of markers in a box, right? So like, I guess maybe it wasn't really the best idea to say that each box represents a box of markers, because really it more like represents what's happening to a box of markers, right? You're starting with X markers in each box and then taking 15 out. So let's see here. Let's first define our variable. X will be the number. You can use the hashtag symbol to stand for number of markers in each box. All right, so you can use any strategy you want at this point to solve for X, figure out how many markers there were in the box. So I'm going to encourage you to pause the video for a second, see if you can figure out what X equals, right? How many markers did did each box start with, and then check your work against mine in a moment. So pause, try it. Okay, welcome back. I know some of you probably didn't pause. All right, so if the whole thing's supposed to add up to 90, right? Well, there's 3 of these like compartments to the tape diagram. So if we split this 90 into 3 equal parts, we get 30. So that means that this has to be 30 right here, this has to be 30, and this has to be 30, right? Like, so each box of markers had 30 left in them after they took the 15 out, right? That's what that means here. And so we could make like our own little like mini equation from this. We could make an equation that says X minus 15 equals 30, right? Or some number that we don't know. So it's like question mark minus 15 equals 30. So in other words, what's 15 more than 30? Well, we get that by doing 30 plus 15, right? 30 plus 15 equals 45. That's like working backwards in the number machine. If you did your independent work on Wednesday, right, there was those number machines, and they would like add something to the input number, and then you would get the output number, and you'd have to work backwards. So you would subtract, or if the machine multiplied, you would have to divide, right? You're doing the opposite. Same thing here. I was trying to figure out blank minus 15 equals 30. So I had to do 30 plus 15. I had to use that inverse operation. That's the whole basis of solving algebraic equations that we're getting to in just a second. So I think the answer is 45. So X equals 45. We should put that on our paper somewhere. And the question is asking us how many markers was originally in each box. So let's answer it in words. There were, sorry, my work is all over the place. I worked here and then here and here and here. I actually don't really like it when people do that, and I did it this time. I try not to do that. there were 45 markers in each box. All right, let's move on. So here's another time when I'm going to encourage you to pause and see if you can do some of this work without me, and then start the video back up and check your work against mine. So see if you can fill in this entire table here. They give you 2 stories and 2 equations. And you got to figure out, okay, does equation A or equation B go with story 1 or story 2? Then you have to define the variables for each one, like what is X representing in each of these. Then you can solve them. And it says drawing a tape diagram is optional, so you don't have to do it. You can use any strategy you want to solve at this point. And then what does the solution tell you about the story? That's like write a little conclusion. That's like basically what we did here. There were 45 markers in each box. So like what's the little conclusion you can make from the solution? All right, so pause, see if you can do this whole table without me, and then press play. All right, so we're playing now, right? Okay, I'm trying to see if I can get this whole thing in the frame here. I might have to like lift this. All right, good enough. Let's see if we can focus a little bit. Story 1 says, a family buys 6 tickets to a show. They also spend $3 on a snack, a singular snack. It doesn't say $3 for like a snack for each person. So I'm keeping track of that, right? $3 on a singular snack. And I'm also noticing that it says 6 tickets to a show with unknown show price, right? They didn't say how much the show costs. That's pretty much anytime a word question does that, that's going to be the thing you're going to represent with your variable. That's going to be the unknown thing. That's the thing you're trying to solve for. All right, and so since there's 6 of them, 6 unknowns, I would expect to see 6x in the equation that represents it, or somewhere where an x is being multiplied by a 6. All right, next, it says Amir has 24 ounces of juice. He pours equal amounts for each of his 3 friends and then adds 6 more ounces for each. Okay. He pours equal amounts for each of his 3 friends. Okay, so it doesn't tell us what that amount is that he poured though, right? So this is going to be unknown amount of juice. And so because there's 3 friends, therefore 3 unknown things, I would expect this equation to either have 3x or an x being multiplied by 3 somewhere in it. All right? And so now, if we look, I see that in this equation, x is being multiplied by 3, right? Not directly, it's written in factored form, right? It needs to be distributed. Well, you don't have to. 3 times x here. So that's my 3 unknown amounts of juice that Amir is pouring here. Okay, and then if I look at the other one had 6 unknown cost tickets to a show, right? And so that one we would expect to see 6x, or 6 being multiplied by x somewhere. And when I look here, I see 6 times x. And so obviously you would also distribute the 3 to the 6 here, and you would also distribute the 6 to the 3. But I was just using what's going on with the variable to help me really figure out which one is which. So I think that equation B goes with story 1, and equation A goes with story 2. And so then they're asking, what does X represent for each of these stories? So we kind of put that up here, right? So in story 1, the unknown was, let's say X is the cost of a ticket to the show. And then for the other one, X was the amount of juice. I don't want to say the amount of juice he pours, because it's like he pours some juice and then he pours some more. And so like it almost, that just saying the amount of juice he pours could be misinterpreted to mean like all of the juice he pours. And so I'm going to say amount of juice originally poured or something. I don't know. You'd have to like come up with a word to say what you really mean here. Mathematicians really care about being like precise in the way they communicate these things. That's like that's a trait of a true mathematician, is like caring that the way you communicate something is precise and difficult to misinterpret. I don't want to be misunderstood. I'm going to use whatever words it takes to make sure you don't misunderstand me, because I'm a mathematician. All right. Next, it says solve each equation. Draw a tape diagram if it helps your thinking. All right, so on the next page, we're going to start only solving equations using the actual algorithm for solving algebraic equations. But here, I want to just use a solution strategy. I want to just use a way of solving these questions that most students are familiar with. So for equation B, or story B, they start off with $24, right? So I'm doing this story in this box. They start off with $24, and they're subtracting, or I'm going to subtract $3 because they spent $3 on a snack, is what it says right here. And so that leaves them with $21. Then they bought 6 tickets to a show. Oh, you know what I'm just now realizing? It does say each right here. Each. They also each spend $3 on a snack. Oops. I don't know. I just completely, my eyes just like went right over that. Okay, so that changes things. So, if they each spend $3 on a snack, and there's 6 people in the family. So first, I'm going to do 6 times 3 equals 18. Right? 6 people spending $3 each on a snack, that's $18. So now let me take 24, the total dollars they spent, subtract 18, and I get $6. There's $6 left over, and they still haven't bought their 6 tickets to the show. So I think it's going to be pretty obvious that each ticket must cost $1. All right, let's do the same thing for the juice one. It says he had 24 ounces of juice. He pours a little bit, equal amount, into each of the 3 cups, and then an additional 6 ounces into those 3 cups. So that's 3 times 6 equals 18. That's for the 6 extra ounces he pours in each of the 3 cups. So that was a total of 18 out of the 24 ounces. So he lost 18 right there. I'm going to do 24 minus 18 equals 6. So that last 6 has to represent the equal amount he put in each cup. So we divide that by 3, and we get 2 as our answer here. So one thing I want you to see is that this is probably how most people would approach this sort of question. If you were to just come back and look at this and not hear me explaining it as I do it, this stuff would be generally meaningless. I did 6 times 3 equals 18. It's not it's not like if you did yours similar to how I did it, your work might look different. You might have decided to do things in a different order or represent them differently or write them differently. And that's a problem because math is supposed to be a form of communication. And if people are communicating differently to say the same things, then the communication aspect of math breaks down. And so that's why this will be the last time that I solve an equation or a problem like this. From when we get to the next page and from there on out, we're only using the proper way of writing algebra and the proper algorithm for showing the work. And that's going to be the expectation for this class from the rest of the way out. Right, but what does the solution tell you about the story for this one? We should say each ticket cost $1. And over here, he originally poured 2 ounces, I guess it would be. Sorry, it's like really hard for me to write here because the paper's all curled up and I'm near the wall and it's like, I can't even put my pen down right. Originally poured 2 ounces in each cup. All right. So when it comes to this solving equation stuff, I've said a couple times that I haven't really taught you how to do this yet. Well, now it's time. We're really gonna go through this process for solving equations algorithmically. Algorithm kind of just means process, like system, step by step. And then this is how I'm going to expect to see it done from here on out. What we're going to do is we're going to take all the equations from this page, from page 81, and we're going to transfer them to page 54, I believe it is. 54. The reason for that is there's more room to work on page 54. 54 is a blank page. And you need a good amount of space if you're going to show how to solve an equation properly. We're also going to write some notes. And those notes and these examples are going to be all right on the opposite page from here, where I don't have them in this book, but you should have some notes from a different video that I made, all up on page 53. And then it's near your other notes, right, for like the lessons that we've done. And so when you're taking a quiz, you'll have all the notes like closer in the same place. So we're gonna convert or transport all the equations on page 81 to page 54, the blank page at the beginning of this whole section of the book. All right, so that's what I'm doing. I'm gonna write this equation here, 6x plus 11 equals 21. You know what? Actually, no. Let's get some notes on the page first, and then we'll know where we can write from there. The paper will turn out nicer from there. Okay, so solving equations. So you're gonna need to send me pictures of this stuff. I'm gonna want to see a picture of page 80 and of this page 54. Just so I know that you followed along with this video and got all these notes and stuff. So solving equations. The goal is to get x, this could be any variable, x, y, a, b, q, whatever, but we tend to use x a lot. So is to get x by itself. Right, we look at an equation and it has 3x plus 92 all divided by 4 equals all this other stuff, right? And it's hard to tell what x equals when looking at that. But if we can get it to where it just says x equals something, x is all by itself, then we've accomplished our goal, right? This process, it's supposed to be an O, process, is called isolating the variable. To isolate something means to get it by itself. So this literally just says the same thing as the previous line, but this is the mathematical term for it. Like, this is what I'll be saying in class. Isolate the variable. Isolate the variable using inverse operations in reverse GEMDAS order, which humorously comes out to SADMEG. When we're solving equations, we got a SADMEG. There are certain ways to do this without following SADMEG order. And sometimes you have options of how you can do things. But in general, if you're working in SADMEG order, you're probably doing okay. So step 1, simplify the equation. This would be like combining like terms, distributing. Sometimes you don't have to distribute in order to solve an equation. Usually you do, and it's always a good practice too. Like if you're not sure, like, should I distribute here? Should I not? Just do it. You can never like hurt yourself by distributing, but you can hurt yourself by like not distributing something that you should have. So when in doubt, just distribute. Okay, step 2. Look at the operations happening to x. So if it says 4x, okay, you've got your x is being multiplied by 4. If it says plus 4x plus 12, okay, my x is being multiplied by 4 and it's being added by 12. Okay, so these are the things that are happening to my x. Step 3, do the opposite, sorry, the inverse operations. Inverse operations are like, the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. Do inverse operations in SAD MEG order. And that's pretty much all there is to it. You do that until you've essentially deconstructed the, to both sides of equal sign, right? Anything you do to one side of an equation, you've got to do to both sides, because that's how the equation stays balanced, equal, fair the whole way. when you're writing this stuff, make sure that um, your operations are on both sides of the equal sign. Sometimes I see students write operations both on one side. If you got an operation on one side of the equal, you should also be on the other side of the equal sign. All right, so we're going to do 6 of them on this page because there's 6 equations on page 81 that we're going to transfer. So here's the first one. 6x plus 11 equals 21. This will be number 1. Oops, I'm way off the screen. Okay, so step 1, simplify the equation. Combine all the like terms, do any distributing you see. There's no like terms to be combined on any side of the equal sign. Like, yeah, 11 and 21 are like terms because they're both numbers, but they're on opposite sides of the equal sign, and we could like combine them, but no, we don't need to. They're on opposite sides. They're fine where they're at. There's no distributing to do, so this equation is pretty much in the simplest form we would expect it to be in. This is a good place to start. Step 2, look at the operations happening to x. Okay, I see x is being multiplied by 6, and I see it's being added by 11, right? And if we were doing GEMDOS order, you would do the multiplication, then the addition. But step 3 says we need to do the inverse operations in SADMEG order, backwards order. That means subtraction and addition come first, then we worry about division and multiplication. And we have to make sure we do those things to both sides of the equal sign. So when you do this, it's essentially a process of showing a step and then a new equation, a step and a new equation, a step and a new equation. And you keep doing that until you get x all by itself. Your variable is isolated. So our first step is going to be to subtract this 11. Our goal is to create a 0. We have a positive 11, we have a negative 11. When you combine those through addition, you get a 0, right? So I'm writing minus 11. I'm really adding negative 11, but those are the same thing. So whichever way you like to think about it, doesn't really matter. So I'll add negative 11 to this side, subtract 11, whatever, same thing. What happens is this plus 11 and this minus 11, they make a 0. And so what we're left with is 6x plus 0 on this side of the equal sign. But I'm not even going to write the plus 0. That's pointless for me to write. Equals 21 minus 11 is 10. I want you to notice something that I've done here. I wrote the 6x in such a way that my equal sign would wind up right where I wanted it. These equal signs, it's really, really good practice, both for your work looking nice and also to help you make fewer mistakes, that your equal signs wind up in a straight line. Some people have a tendency to sort of move this around because your equation tends to get shorter and shorter as you work. So then, like, where things lined up get all weird. Don't do that. Just continue to write it so that the equal sign is always in a nice straight line. Some math teachers will literally force you to always draw a straight line through all your equal signs as you do this. I don't force students to do that, but it's a good idea to do it. All right, and so now my next step, because I have multiplication against my variable, I want to use the inverse operation. I'm going to divide. I'm going to divide by 6. You can use a division symbol, or you can use a fraction bar. Both of those are okay right here. And so what happens is, like, you almost should think about this as a fraction, right? Like 6x over 6 as a fraction bar. In fact, I almost wish I'd use a fraction bar instead, but whatever. If you have a 6 on top and a 6 on bottom of a fraction, they make a 1, right? And that's what happens here. This 6 that's multiplying and the 6 that's dividing, they divide each other and they become 1. So what we're left with is 1x. I'll put the 1. I don't normally write that 1, but I will this time. Equals 10 divided by 6 is 10 sixths. Or I guess you could write it as, what would that be? 1 1.1, is that 1 2/3? Yeah, 1 2/3, which would be 1.6 repeating if you were to put it in a calculator. So you could write this, I don't like repeating decimals and stuff. So honestly, I just use the improper fraction. 10 divided by 6 is literally just 10/6. You're allowed to do that. You can simplify it if you want. It would be 5/3. And so I'll write one last line that just says x equals 5/3. And so this right here is what we would call a two-step equation, because we started with our original equation, and then what you get is a step, right, where I decided to subtract 11 from both sides or add -11 to both sides. We would call that a solution step or just a step. Then what results from that is a new equation. I often abbreviate equation as EQ, so just get used to that. Then we did another step, and we showed it here. We divided by 6. And then lastly, we wound up at a new equation, 1x equals 10 over 6, or x equals 5/3. These are all kind of the same equation. So new equation. This is how your work should always look. Original equation, step. New equation that results from that, step. New equation that results from that, etc. We'll probably never really do too many equations that take more than like 3 of these orange steps to solve. 2 is sort of like the average for 7th grade. Like we'll do a lot of these 2-step equations, 1, 2-step. And we'll also do some 1-step ones where you literally just got to do one thing and then it's done. So 1-step, 2-step, 3-step, that's probably where we'll be most of the time. All right, let's go get another equation from page 81. We got 6 times quantity x plus 1 equals 24. So I'm going to do this so that I'm going to try to fit 3 equations across here and then a whole nother row of 3 equations. So if you weren't able to write this as small as me and fit all this stuff in the same way as I am, then just grab another piece of paper, write more on it, and then like you could tape it or glue it over this junk right here on page 55 that we don't need. Whatever works for you. I really wish this wall wasn't here. It's like really making my job harder. All right, I already forgot what the equation was. What was it? 6 times quantity x plus 1? Yeah, 6 times quantity x plus 1 equals 24. So I'm going to do this one in reverse. I'm going to write the equation in orange. No, I'm not going to do that. I'm going to keep the same color pattern I had. So this is equation 2. And this is going to be 6 times quantity x plus 1 equals 24. All right, so you should have seen me do a couple of these in class where we have 2 options here. We could divide both sides by this 6 and get rid of it, or we could distribute the 6 and then handle the equation from there. Just for whatever, let's follow the steps the way they say. Let's simplify the equation by combining all the like terms and distributing first. So I'm going to distribute the 6. You don't have to do this. It's just one of a couple strategies you could choose from here. So 6 times x is 6x. 6 times 1 is 6 equals 24. Don't distribute that 6 all the way across the equal sign there. It doesn't work that way. All right, now my thing's all simplified here. It's in standard form. So let me go to step 2. Look at the operations happening to x. Okay, I see it's being multiplied by 6, and I see it's being added by 6. Next, do the inverse operations in SADMEG order. And make sure to do them to both sides of the equal sign. Okay, so my operations are multiply and add. So I'm going to need to use subtraction and divide. And I got to do them in SADMEG order. So I'm going to subtract, then I'm going to divide. So let me subtract 6. Remember, the whole goal is to do the opposite of what you see, because that makes zeros and it makes ones and it makes things go away. It's like we're chopping away at this equation to just get just that x in our hand. So I got to subtract 6 from over here. So plus 6 and -6, they make 0. So I'm left with just 6x. Oops, I want to switch to black. Equals 18. Notice my equal signs are, in a, I mean, maybe not a perfectly straight line or whatever, but they're not like way over here and here and here. All right, and now my next step is to divide both sides by 6. This time I'm going to use a fraction bar to represent my division. We can do that. When you do this though, you're dividing the entire side of the equation by 6. One thing I've seen some students mess up is that they'll have a big old long equation with a bunch of pieces, and then they'll just divide like one piece of the equation by 3 or by 2 or whatever. No, if I do this, I'm dividing everything on that side of the equal sign by 6. And that's a big part of the reason why we wait to do multiplication and division last, because those things can get messy. All right, so this 6 on top and bottom of the fraction, they make a 1. So we're left with 1x. I'm just going to write it as x though. And 18 divided by 6 is 3. So x equals 3 on this one. Now what I want you to do, pause the video, verify this solution. You don't have to write it though. You can probably do it in your head. Put this 3 back in for x in the original equation and see if it works. Does the left side come out to 24 like the right side does? Does it? Pause it and think about it for a second. So hopefully you put the 3 here. 3 plus 1 is 4. Multiply by 6, you do get 24. That's how you verify your solutions. That's how you make sure you got the right answer, which we did. All right, let's go grab another equation from page 81. The equations are going to come from this diagram here. They gave us these tape diagrams and they want us to write the equation over here and solve here. We're just going to do it on page 54. So let's see here. I got 4 quantities of a plus 3 here. So that's 4 times quantity a plus 3, and it's supposed to equal 56. All these are going to equal 56. All right, so 4 times quantity a plus 3 equals 56. All right, so this time, I'm not going to distribute first. Let's look at how the other way to do this type of equation here. So step 1 says simplify the equation, combine like terms, and do your distributing. Most of the time you want to distribute, because if your distribution is happening in the middle of a big equation where there's other things going on, it'll mess you up if you try to use this strategy. But this strategy works because this factored form expression, this one distribution, is the only thing that's there, and that allows us to do this. I'm going to divide both sides by 4, and see, notice I'm putting that fraction bar over under everything, right? Not just the 4. But what happens is I have 4 times some junk over another 4. Well, that creates a 4 over 4 in the fraction, and they make a 1. Lots of people like to cross things out here. They say cancel out. And what you're left with is 1 times quantity a plus 3. But that's just a plus 3. So we get a plus 3 equals 56 divided by 4 is 14, I believe. Okay, so some number plus 3 equals 14. You should be able to figure it out in your head that that's going to equal 11. But that's great that you can do that, but we still have to make sure we know how to write it properly. So if you're not following along with this and you're not writing this stuff, I need you to understand that you're not doing the thing. Like being able to tell me that like a plus 3 equals 14, like the answer must be 11, that's not the goal here. The goal is learning how to write this stuff properly. A, because it's going to make you a better math communicator, and B, because when you get into 8th, 9th, 10th, 11th grade, whatever, you're going to get equations where like no regular person could just look at them and be able to like do it in their head and figure it out logically. And the only way to get to that solution is breaking it down piece by piece by piece, doing this method. It seems easy now because I'm giving you 7th grade stuff. It's training wheels, right? But you need to know this process for when you get bigger ones, because it's just this, but more. All right, so let's subtract 3 from both sides, and we get a equals 11. Let's go back to page 81 and grab another equation. Here we got b plus b plus b plus b plus 3 equals 56. So that's 4b plus 3 equals 56. So this will be number 4. And it's 4b plus 3 equals 56. All right, so I look at what operations are happening to my variable. It's being multiplied by 4. It's being added by 3. I'm going to use subtraction and division to get rid of those things, and I'm going to do it in SAD-MEG order. By the way, SAD-MEG is a Mr. Thomas thing. Other mathematicians don't say SAD-MEG. So if you're ever in another math class and you say SAD-MEG, they're going to be like, what the heck are you talking about? All right, so I'm subtracting 3 from both sides. Plus 3 and minus 3, they make a 0. So I'm left with 4b, making sure my b's look like b's and not 6's, equals 53. Oh, this one's going to come out to like a weird decimal or fraction. Did I copy this right? Yeah, I guess so. Okay. Your equations aren't always going to come out to nice whole numbers. That's part of life. So I'm going to divide both sides by 4 here. So let me use a division symbol this time. And I get 1b, making sure that my b's look like 1s, because 1b can look like 16 real quick, equals, let's see here, 53 divided by 4. If it were 52 divided by 4, that'd be what, 13? No. If it was 52 would be, no, that would be 13. I was right the first time. So if it was 52, it'd be 13. But what I have here is 1 left over, so that's 1/4. So this is 14 and 1/4, or 14.25. See how I started to accidentally sort of write at an angle here, and my thing started to kind of get curved? Try not to do that. I just wasted page space. It's not a proper way to do it. My equal signs are out of line here. So this was bad. That was a bad job by me. Ooh, and I forgot my color coding there too. I'm getting lazy. All right, let's go get our 5th equation. We have 3 quantities of c plus 4. So this is going to be 3 times the quantity c plus 4 equals 56. They're all 56. Three times the quantity c plus 4 equals 56. I will choose to distribute this time. You don't have to, but it's kind of like my preferred way. So 3 times c and 3 times 4, I get 3c plus 12 equals 56. This is an equation line. It actually should have been black, not orange. Oh well. All right, and so now I'll do my first step in orange. I see multiplication and addition, so I'm going to use subtraction and division to work backwards. Let me subtract 12 from both sides. Plus 12 and minus 12 make a 0, so I'm left with 3c equals 44. Well, they really like giving us ones that come out to decimals and fractions, huh? All right, so we got 3 times c. We undo that with division. We're going to divide both sides by 3. I'm going to use a fraction bar this time to represent my division. That should have been orange. Man, my color coding's like all off. All right. And so what we're left with is c equals, let's see here, 3 goes into 42 14 times. And then you're left with 2/3 left. So I don't like writing my answers in mixed numbers or repeating decimals. So I'm gonna just do it this way. I'm gonna write it as literally 44/3. I like improper fractions. They don't bother me at all. All right, 44 divided by 3 is just 44/3. We can do that. All right, last one. D plus D plus D equals 4, or plus 4 equals 56. So we got 3D plus 4 equals 56. All right, you should be starting to get pretty good at this, so I'm not even going to explain it as much as I go. I'm going to subtract 4 from both sides. I get 3D equals 52. I'm going to divide both sides by 3, and I get D equals, maybe this is going to be another one where I just write 52 thirds, because what is 52 divided by 3? It's probably some repeating decimal with like 3s at the end. I'm going to just double check it. I'm going to use the old calculator. I'm going to go 52 divided by 3. Yeah, so 17.3 repeating. I mean, if you really wanted to, you could write it that way. 17.3 repeating. Boom. All right, so this is like your master page for solving equations. Everything you need to know about solving equations is right here. A bunch of examples are here for you. Look at this when you're taking a quiz, refer back to it if you're ever getting stuck, but this is the process. And this is the way that I'm gonna look for your work to look when you solve equations from here on out. All right, have a good spring break.